Hello and welcome to 5 Minute Math. Today we are looking at the advanced level of the 3.2a readiness practice for composing and decomposing numbers. If you are interested in the intermediate or the proficient levels, you can find those and all other resources using the link to the document in the video description. So our first question looks at Farmer Fred, and Farmer Fred has quite a bit of pumpkins here, and we need to show those pumpkins in four different forms. So I'm going to rewrite his total here, 87,056. And what I want to do is I want to put it in a place value chart. Now my place value chart, what I like to do is I like to put the value of each place underneath the digit. So the 6 is in the ones place, 5 is in the tens place, the 0, which there's nothing there, is in the hundreds place. My 7 is in my thousands place, and then my 8 is in my 10,000s place. So I'm going to start by writing this in word form. Now, how we write this in word form is we put the number that is between each set of parentheses, we put that down first, and then we say the name of that family unless it's the last family. So this is our thousands family, right? We've got our thousands, our 10,000s, our 100,000s if it went that far. And then this is our ones family. That's the family name we don't necessarily say. So if I wanted to say what was in the thousands family, well, I would just say those two numbers, the 8 and the 7 together would be 87. We're going to use a hyphen here to separate 80 and 7. And I'll say the family name 1000. Then you say the rest of it, 56, and that's the one in which you do not say the family name. So 87,056. We're not going to say and 56. The and is reserved for when we're talking about decimals and starting in fourth grade. So that's it. The word form is 87,056. So let's look at our unit form. So what our unit form does is it takes each digit, we'll start with the largest digit, 8, and then simply names the place value. So that 8 is in the 10,000s. All right, so let's say 8 10,000s, and then we're going to add it like we would expanded form to the next place. So I've got a 7, and it is 7,000s. Now I'm skipping that 0. There's nothing in the hundreds place, so I'm going to go straight to the tens. So I'm going to say 5 tens. And finally, I don't just have 6. What's that place value? It's 6 ones. All right, now expanded form and expanded notation are similar. So let's first look at expanded form. That's the one that we've been working on. Most of us in second grade, some of us might have seen it in first grade as well. And so expanded form takes the value of each digit, starting at the largest place value, so that 8 10,000s, right? 8 in the 10,000s place. Well, if you skip count by 10,000 8 times, 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, 70,000, 80,000. That's that same value. 8 10,000s is worth 80,000. And I'm going to write it underneath here so we can see how it all lines up. 7,000s, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. Right? No 10 or no 100, so we're just going to skip that. 5 tens is worth 50, 10, 20, 30, 40, 50. 6 ones is worth 6. So what I do with my expanded notation that's new for third grade is instead of writing the value of each digit, what we're going to do is we're going to write the digit. So I'll start with 8, and we're going to multiply it by its place value. So 80,000 is 8 times 10,000. Because 8 10,000s, I can either add 10,000 plus 10,000 and 10,000 8 times, or that's repeated addition. You know, repeated addition can be represented as multiplication. So we're going to do 8 times its place value. Same with the thousands place. 7 times 1,000. And what I'm doing is I'm adding these partial products, skipping the 100 again. I've got 5 tens. And then I've got 6 ones, but I'm going to write 6 times 1. I'm not just going to write 6. So we see how they line up. The unit form, the expanded form, and the expanded notation all line up. So that is our first problem. So for our second problem, we have a local zoo, has a Name the Elephant contest, and we've got this number. Let's go ahead and write that number here. 20,832. And I'll write that same place value notation. Ones, tens, hundreds, thousands, and 10,000s. I need to write it as the sum of so many 10,000s, so many thousands, etc. in 4 different ways. And for 2 of my answers, I need to create a sum with no 10,000s or thousands. Now that's going to be very difficult, but this is advanced, so we can do it. So those just need to be 2 of my answers. I need to show at least 4 different answers, so 2 of my answers can include 10,000s and thousands. And so let me put down here that your answers might be slightly different than mine. So I'm just going to go ahead and write answers may vary, but I will show you some options. And so we can start by looking at this in unit form. That can be one of our options. How would we write this in unit form? Okay, so I could do 2 10,000s. I don't have any thousands. Plus 800s plus 3 10s plus 2 1s. Okay, that's one way, but I can't do that 3 other times, and that uses thousands and 10,000s in the challenges. I can't use them in 2 of my answers. So let me show you one way to look at it. We'll start with the easiest way to look at it. If I group these 2 right here, that's 32. So 32 is 3 10s, 2 1s, but we could also get 32 by just saying 32 1s. So the trick with these problems is you can always think of different ways to look at it if you take 2 of the digits, and then what you end up doing is you name it by whatever place value that final digit is in. Because if I wanted to give you $32, I could either give you 3 10s and 2 1s, or give you 32 1s. They'd both equal $32. So let's say 2 10,000s. We're going to keep this first part the same. We're going to say 800s. But when we get to the end here, instead of 3 10s, 2 1s, we can say 32 1s. Now that's going to help us because we need 2 answers that have no 10,000s or thousands. And so we have some options. We can use what we just learned to do that. So let's use this color here and let's think. I don't want to, if I could group the 20, I could say 20,000s is the same as 2 10,000s, but then that would still have thousands. So I need to make my group slightly larger. So what if I did this? All right, so let's see what this is going to look like here. So I have together 208. And 208 what? What is the place value that it's in? Well, the final place value is sitting in that 100 spot. So I have 208 hundreds. So if you take $100 bills and you count out 208 of them, you're going to get 20,800. So that's how this works. So think if you count out 10 hundreds, you get 1,000, right? 20 hundreds get you 2,000. 30 hundreds get you 3,000. If you get 100 hundreds, now you've got 10,000. You do that twice, you've got 200 hundreds. Now you've got 20,000, and then an extra 8 gets you 2,000, 20,800. And so let's do this. Let's do this in the correct color here. So I've got my 20,800. So I'm going to write my 208 hundreds. And now I can go back and I can add my 3 10s plus 2 1s. Or hopefully you see what I did. If I wanted to, I can make my fourth option being 208 hundreds. And I could also regroup if I wanted to the tens and the ones. And I can say 32 ones. You could also have grouped larger, right? You could have said 2,083 tens. That would have worked. Or you could have said 20,832 ones. That could have worked. So those are just some of the answers that could work here for our second problem. And our third problem, we have a mystery number. So our mystery number has got, I've got thousands. It looks like it goes to my thousands place. So I'm going to write this out here. All right, so I'm going to say ones, tens, hundreds, thousands. Okay, 4 ones. That's pretty easy. I've got 80 tens. Now this is like the previous problem. You can't write 80 that you don't have 2 digits in one spot. Each spot can only have 1 digit. So we use what we learned in our last problem. 80 tens would look like this. You take your 80 and then the last digit needs to be in the place value that's named. All right, so 80 tens is the same as 800. So right now, 4 ones and 80 tens is 804. And then I've got 17 thousands. Well, I can't do that, so it needs to spill over. So it looks like I need to add another place value. So this problem really combined, your tens and your hundreds, and then your 10,000s and your thousands. So I need to write this now in standard form. Well, I've already written this in standard form, basically by working this out on my place value chart. It's going to be 17, comma, 804. Now expanded notation. So this is where we are writing it as the sum of each digit times its place value. So it's 1 times 10,000 plus I've got a 7 in the thousands place plus I have an 8 in the hundreds place. Skipping the tens, there's nothing there. 4 in the ones place. Now I need word form. All right, so once again, we need to note each family. So this is my thousands family. My thousands period, it's separated by the comma. This is my ones. And so I'm going to say the whole number in the family 17 is 17. And then I'll say the family name. So 17,000. Still use the comma in the same spot. And then 804, 804 would be 804, not 804. We're saving our ands for decimals starting at 4th grade. 804, and then we don't say the family name. And then I need expanded form. So my expanded form is going to be similar to my expanded notation. All right, so I'm going to take the value of each digit. So 10,000 is worth 10,000. 7,000s, right? And I can write it underneath the expanded notation. I can spread it out just a little bit here. It's going to be 7,000. 800s is going to be worth 800. And then 4 ones is going to be worth 4. So that's the answer to number 3. If you are interested looking at the intermediate or the proficient levels of 3.2a readiness practice or any other readiness practice, you can do so by using the link in the video description.